All right, 5.3 continued. We already worked on conditional probability. Today we're going to move on and work on the general multiplication rule to calculate probabilities. And this goes hand in hand with the tree diagrams we'll be working on today to model the chance process. Okay. All right, and then we'll also get into determining whether two events are independent. This always seems to show up on free response of the AP exam, at least like every other year, seems like. Okay. All right, so here we go. Let's get started. Okay, so on page 321, they show this general multiplication rule and the proof. The proof is really simple, one algebra step, but it's important to show you this because this general multiplication rule, I'll show you the application in a moment, this formula right here is not on your formula sheet, but you can get it right from this conditional probability formula. Okay, how would I solve this for probability of A and B, which is what this is, right? All we'd have to do is multiply this by probability of B. Oh, pen's not working. There we go. So if I multiply that, right, and then balance the equation, this is what we get. Probability of A and B equals probability of B times the probability of A given B. Already happened. Okay. Here in the notes, they kind of switched this around. They have the A first, but notice it was given A already happened. All right. So let me just show you kind of a real simple example of where we'd use the general multiplication rule. And this is what's a little different. There's kind of like two events are happening now. Where in section 5.2 is just one event, drawing a random card or something like that, drawing a person. Two events typically are happening with this situation. Or one event has already occurred. So let's just say, what's the probability of getting two heads when you flip coins, right? Well, what are all our possibilities of flipping the coin twice? We could get two heads, we could get two tails, we could get head, tail, and tails, heads. That's all our possible outcomes. So probability of getting two heads is 1 out of the 4, right? Now here's the shortcut. Probability of getting heads times the probability of a second heads given the first one was heads. All right. Now it's still 1/2, right? Probability of getting heads is 1/2. And then of getting a second heads given the first one, these are independent events, so that doesn't really affect this. Okay. So I'm kind of getting into independence as well. Getting ahead. So we get 1/4. So we multiply these together and we get 1/4. There's the multiplication rule. Okay. And if I have 3 tosses, we just keep multiplying. 1/2 times 1/2 times 1/2. Okay, so there's a quick little intro. You may want to make note of what I mentioned. They're mentioning it here. This rule says that for both of the two events to occur, first one must occur, and then given that the first event has occurred, the second must occur. Okay, so this now means that kind of 2 events are occurring in succession, which is different than what we had in section 5.2. Okay, but that might be enough of an explanation for you. Maybe you don't need to write that down. Okay, so let's look at example 15. Read this to yourself. Okay, now I know this guy might be throwing you off a little bit. Like, it's not 2 separate events, but still one thing had to happen, and then the second one happened because there was a kind of a given condition. All right, so what do we know? This was given. I want to write this down. The probability that they were online or using the internet was 0.93. Okay, they also gave us this. 55% of the online teens, so that's like a given condition. So 55% of them have posted a profile on social networking site. So probability of a profile given that they're already online, 0.55. Okay, so what's the probability that a randomly selected teen uses the internet and has posted a profile. So we're going to use this formula now. Okay. Now I put it into context. That might help you. So online and has a profile. So we need to take the probability that they're online times the probability of the other events. So online profile given that they're online. It's like a percentage of a percentage. This is the number of kids that are online. Well, not all those people have a profile. So we take 55% of those people that are online, if that makes sense. Some of you guys are getting a little better at the number sense, right? We should take a percentage of that. And so that's basically what we're doing to get 0.5115. Pause if I'm going too fast. Okay, so show your work. We did. Here's the context to make sure you understood what we found. There's about a 51% chance that a randomly selected team uses the internet and has posted a profile. All right, now these tree diagrams, which is an extension of this property, of this multiplication rule, take up a lot of space. So I want you to go to this tennis example on page 322 about Roger Federer. Read it for understanding, and then we'll discuss it, and then we'll go through one as well. Okay, so pause now. Okay, sometimes students wonder, when should you make this tree diagram? Well, tree diagrams are going to help you when they start talking about percentages of percentages. So they told us that 63% of the time, he makes his first serve. Okay, now of that, they said 78% of the time he won. They didn't tell us this 22%, but we got to understand and kind of do the math and understand these are complements of each other. So 78% he wins, then he lost the other 22%. Okay. All right, but this percentage of winning goes lower. I don't know if you know anything about tennis, but usually if they don't make their first serve in bounds, they didn't lose a point yet. Okay, but then when they go on to their second serve, they have to get it in. Otherwise, so they got to be more careful. It's not as aggressive, not as fast, because if they don't get this next one in, they lose the point. Okay, so that's why these percentages drop. Anyways. All right. So anyways, we're taking percentages of percentages here. So after he makes his first serve, 78% of those 63%, he wins. So that's why we use the multiplication rule here. Okay. They're kind of like little strands. Multiply, we get this number. Okay. So that's the probability he makes his first serve and wins the point. And then we just keep following these strands. Okay. 22% of the 63, he loses. We get this number. Okay. All right. And these are the only four possibilities, right? He either made his first serve, won or lost, or he didn't get his first serve in and he won or lost. So naturally, we'd expect all four of these numbers to add up to 1 or 100% of the outcomes. Okay. That's what's kind of cool about this and how it works out. That is a fact we can lean on. Okay. All right. So there's our first intro to this. Let's try it. Let's go to example 17 in your notes, and I'm going to take you through. All right, go ahead and pause and read this if you want, if you haven't yet, because I'm going to keep going here. Okay, again, they're talking about percentages of age groups, age groups. That can be pretty tough to keep track of just all in your head. This is where a tree diagram is going to help you. So that's what they're doing for part A. So here we go. Let me take you through this and let's do it. We have internet users age 18 and above. That's kind of our main topic here, right? All right. Now, out of those internet users age 18 and above, 18 to 29 of them, the age group 18 to 29, 27% of them are in that age group. Okay. And then we keep going. They also told us 45% are in this age group, 28% over 50. And it's pretty common to just draw put the probabilities on that stick, if you will, of the tree diagram. Okay. or branch. Okay, then they went on to tell us that of the 18 to 29-year-olds, another, where's it at here? 18 to 29 have visited a video sharing site. So 70% of them. Okay, so if 70% of them visits a video sharing site, then we know that 30% do not. They didn't give us that number, but we're doing the complement rule here. Okay, and we continue to go back to the reading, and they told us that in this age group, 51% visits a video sharing site, like YouTube. That means 49% do not. Okay, and then here's the last branch. Okay, go ahead and pause to write that down. I'm going to pause to get ready for part B and C. All right, here we go. Part B. Find the probability that this person has visited a video sharing site. All right, so that's why we did all this work. It's going to help us figure this out. The people that visited a video sharing site are these strands. This number here. How do I get it? 0.27 times 0.7. Do the math. These people also visit video sharing sites. So 0.45, right, times 0.51. Actually, I have to work down here, so I'm going to stop doing this here. But it's these three strands that I started. Okay, so the probability that they visit a video sharing site is the sum of these three products. Okay, I'm going to keep going, so pause if needed. That gives me 0.4913. Okay, again, I'm going to keep going. C. Okay, given, this is a conditional probability, I can tell already, given that this person has visited a video sharing site, find the probability that he or she is aged 18 to 29. All right, remember, we just found the probability of them being on YouTube, right? It's already these three things. Now we got to find the probability that they were just in this age group. So it's this group divided by all of it. Okay, so here's the formula that we're using. Here's what we should write down. This is what they're asking. The probability that they're in this age group given they have visited a VSS. Okay. Following this conditional probability formula, whatever is given goes on the bottom. And then we have A and B up top. Okay, so what was the given condition? Visit a VSS. Okay, up top, it's the combination of both A and B. Okay, keep going. All right, so let's grab our numbers, and we got it. So visited a VSS, we just answered that in part B. I'm not going to reinvent the wheel. 0.4913 goes here. And then what's the probability of this and that? It's just that single strand, 18 to 29 and visited VSS right there. So that goes over that, and we get 0.3847. Okay, so here's the interpretation. I'll zoom out too because I don't think I slowed down for the interpretation of part B. So there's the interpretation for both. Pause to write it down. I'm moving on. Okay, let's take a look at another tree diagram, example 18 in your notes. Looks like I'm going to get chopped off on time, so I am going to stop this video. And as we're making the transition, and before you pick up, read example 18, and then we'll kind of work through this together.